Good day to all. Today we are going to see about the thermal model of motor for heating and the cooling. See, an electrical motor and drive operates. There is a generation of heat inside that motor. If any motor is operates or running, there might be some heat is generated inside the motor. That is natural. Then that amount of heat generated inside the motor should be accurately accurately as possible. That is why the thermal modeling of motor is necessary. The amount of the heat generated inside the motor should be known as accurately as possible. That is the that is why we are using that thermal modeling of the motor is necessary over here. The material of the motors and the shapes and size of the motors are not unique. As we know, all the motors are in the shapes different as well as size also different. All the motors are not same, that we know already, but the generation of the heat does not alter very much depending upon these characteristics. With the size and shape, depending upon the size and shape, the heat will not change. The most of the heat will occur when the motor is running. So, a simple thermal model of any motor can be obtained, assuming it to be a homogeneous model. The main aim of this modeling is to choose appropriate rating of the so that the electric motor does not exceed its safe limit during the operations. The main aim for this modeling is to choose the appropriate rating of the motor, so it won't not get affected or it does not exceed its safe limit during that particular operations. Then at the time t, let the motor has the following parameters. This P1 equal to heat developed is the joules per second or watts. Then P2 heat dissipated to the cooling medium in watts, and W weight of the active force of the machine that we assume. Then H equal to specific heat, which is joules per kg per degree centigrade, and cooling surface meter squared. Then D equal to coefficient of heat transfer, with has a unit of joules per second per meter squared per degree Celsius. Then theta equal to mean temperature rise with the degree centigrade. Now, if time dt, let the temperature rises the machine to be d theta. The changes will occur for that d theta. The heat is absorbed in the machine is equal to heat generated inside the machine minus heat dissipated to the surrounding cooling machines. That is the main thing. See, if you want to take a heat absorbed in the machine, means we have to calculate how much heat generated inside the machine and how much heat dissipated from that machine, particular machine. So if we get subtracting of those two, then we will get that exact absorbed machine heat. That's we are saying here. Then where d theta equal to P1 dt minus P2 to dt. Since P2 equal to theta dA, then substituting this 2 in 1, we will get substituting this P2 value over here in that here we will substitute this P2 value. Then what will get? We get that C d theta by dt equal to P1 minus d theta. Here C is called the thermal capacity of the machine in watts per degree centigrade, and D is the heat dissipation constant in watts per degree centigrade. Then when we acute the first order differential equation of that particular above equation, then we will get that C d theta by dt, which is equal to P1 minus d theta. P1 minus d theta, we get theta equal to theta double s plus k into e power minus t by tau. Here it is k into e power minus t by tau. The theta equal to tsv. P double s plus k e power minus t by tau, where theta double s equal to p1 by t and t equal to c by d. Then we obtain the values of k by putting t equal to 0. Then this equation, see here, this third equation will become, we get theta equal to theta double s into 1 minus k into e power minus t by tau plus theta 1 e power minus t by tau. So from the above equation, we can find out the rise in the temperature inside working machine, which means the increasing in the temperature inside the working machine, which is very near to being accurate. And if we plot a graph for the variation of temperature is with the time during the heating and cooling, and thus the thermal modeling of motors gets completed. So the electrical motors are used and control them the electric drives are employed, but the operating time for all motors are not the same. This is the main thing. The operating time of the all motors are not the same. Some motors have some operating time, some motors having some less number of operating time, some more motors having more number of operating time. Depending upon the application of the motor, it will have a different operation timings. Likewise, here the motors used to control the electrical drives are employed, but the operating time for all motors are not the same. Some of the motors runs all the time, and some of the motors run the time is shorter than the rest period. See, the thing is, some motor runs time only, running time is very less time. That's denoted here. Some motors running continuously without gap. Some motors gets run completely and continuously. The thing is, if the motor is running slightly, means it will heat generator. For example, we will take our mixie. The motor running only short duration will have the more number of heat over there. Likewise, we will use that particular motor which will have a less heat while it's running a more time. As well as if that motor is not needed here, because this run time is very shorter than that rest period. The run time is very less over here because the running time is less. Depending upon this, the concept of motor duty class is introduced, and the basis of this duty class of the motor can be divided 8 categories. That we will see those eight categories. Before that, we will see over here the main concept of this thermal motor means we will have some heat while it's running, as well as cooling also needed for certain time. If you are giving more cooling for that motor, then that motor may get damaged. That's the main thing of this thermal motor for heating as well as the cooling. Here we will denote these electric motors and drive operators that generate the heat inside the motors. So we will conclude with this: the motor should not be heating the more time. That's all about the thermal motor heating and cooling. Thank you.